Hi there, and welcome to my favorite part of the brain, the hippocampus. The hippocampus is located deep within the brain, medial part of the temporal lobe, as you can see in this picture here. The hippocampus is in the blue. Some basic functions of the hippocampus, just to name a few, are regulating learning, memory encoding, memory consolidation, and spatial navigation. Processing memory is what we're going to be starting with. Now, the hippocampus is often been referred to as the brain librarian. This is because it's responsible for acquiring, storing, and retrieving information from memories, and then it sends that information out to other parts of the brain, such as the amygdala. It can be connected to a librarian because, much like the hippocampus, a librarian takes books from people, puts it on their corresponding shelves with other likely books, and then when another customer comes in and says, hey, I want a fantasy book, the librarian knows exactly where to pick it out on the shelves, specifically for the customer who wants it, picks out a tailored book for that customer, gives it to them, sends it away until they bring it back. So that's how it connects to the librarian, how we can connect the hippocampus, yes, the hippocampus to that role, if you will. Now, there are three main parts of the hippocampus: the dentate gyrus, the entorhinal cortex, and the parahippocampal gyrus. As you can see in these three pictures, it makes this cool little S shape, kind of like a seahorse. Hippocampus means seahorse in Greek, so that's where that name originates from, as well as the shape you can see. Now we're going to break down some processing memory, and I know this picture on the screen looks a little scary and it looks like a bunch of lines and dots, but we're going to break it down and hopefully it makes a little more sense. So memory comes in through the entorhinal, there we go, cortex right here. So let's say you're walking down the street and you see a little kid riding a bike and you're like, oh, I remember when I learned how to ride a bike. So that memory, boom, enters in through doorway number one, the entorhinal cortex. And the entorhinal cortex acts as a hub for memory networks, so it stores all the information in there. Then a bundle of cells in the entorhinal cortex sends granule cells to the dentate gyrus, and that is pathway number one. So just to refresh, you get a memory, it enters through doorway number one, the entorhinal cortex, and that sends granule cells to the dentate gyrus through pathway number one. After it's in the DG sends signals to CA3 pyramidal neurons through mossy fibers, and that is pathway number two. So we enter in pathway number one, it gets processed, pathway number two to your CA3, and from there pathways connect, sending memory to chordal and subchordal regions through hippocampal gyrus. So you come in through EC, get shot into the DG, then some mossy fibers shoot you over to the CA3, and then you get spit out the hippocampal gyrus, which is also pathway number three. One of the main reasons that I picked the hippocampus as my favorite part of the brain is because of its connection to music. I love music. I play a lot of different instruments. I love listening to music and researching how music affects the brain and why it makes you feel certain ways. And a lot of that has to do because the hippocampus is the main navigation system or center for memory retrieval and emotional regulation. This is linked to emotion due to its role in the hypothalamus, pituitary adrenal axis for stress response. And this connection leads to the neuroprocessing of music. There's a really beautiful study on an interview of an elderly woman who has Alzheimer's, I believe. And she used to be a ballerina, and she can't remember, her memory shot, she can't really remember anything. But she hears the music of, I think it's Black Swan or Swan Lake, one of the swans. And she hears the music from one of her choreography dances in the ballet, and she remembers the choreography spot on because of that music stimuli and that emotional connection in the brain. It's a beautiful thing. You definitely look it up if you have time. It's amazing. Another reason why the hippocampus is connected to music is because the main task of the hippocampal auditory system is long-term auditive memory. Music stimulates the right hemisphere of the hippocampus, which is involved with emotional processing of music. So let's say if growing up, you always went to dinner with your dad on Saturdays, and every time you went to dinner, you listened to one particular song. Odds are, if you hear that song on the radio or in your AirPods walking to class, you're going to instantly remember those Saturdays going to dinner with your dad because of that emotional connection in the hippocampal auditory system and the long-term memory found in the right hemisphere of the hippocampus. So we can really thank hippopotamuses. Ha! Gotcha. Just kidding. The hypothalamus, not even hypothalamus, hippocampus, 3 times gotcha. We can thank the hippocampus really for our lives because without it, we couldn't learn new things and life would be extremely boring. And we wouldn't have the ability to make memories or feel emotions or be human. So thank you, hippocampus.